Our sun is huge, at least that is what most of us grew up thinking. It is so big that over 1 million Earths could fit inside it. 1 million, that sounds enormous, and compared to our planet it absolutely is. But compared to some other stars out there in the universe, our sun is tiny, not just a little bit smaller, embarrassingly small. There are stars out there so unimaginably large that if you placed one where our sun is right now, it would not just cover Earth. It would swallow Mercury, Venus, Earth, Mars, Jupiter, and everything in between. The entire solar system gone, swallowed whole inside a single star. Today we are talking about the biggest star ever discovered, a star called UY Scuti. And by the end of this video, you will never look at the night sky the same way again. Before we talk about UY Scuti, let us start with something familiar. Our sun. The sun has a diameter of about 1.4 million kilometers. Earth has a diameter of about 12,000 kilometers, so the sun is roughly 109 times wider than Earth. If the sun were the size of a basketball, Earth would be a small marble sitting next to it. Already the scale is hard to imagine, but scientists measure star sizes using something called solar radii. One solar radius is simply the size of our sun. So when a star is described as 500 solar radii, that means it is 500 times bigger than the sun. Keep that in mind because the numbers we are about to go through are going to be hard to believe. For a long time, the most famous giant star people talked about was Betelgeuse. You have probably heard of it. It is one of the brightest stars you can see in the night sky without a telescope, and it sits about 700 light years away from Earth. Betelgeuse is what scientists call a red supergiant. It has a radius of around 700 solar radii, 700 times bigger than our sun. If you put Betelgeuse where our sun is right now, its surface would reach past the orbit of Mars. Earth would not just be close to it, Earth would be inside it, completely swallowed up within the body of that star. And for a long time, Betelgeuse was the go-to example when people wanted to talk about how enormous stars could get. Then scientists started finding things that made even Betelgeuse look small. Meet UY Scuti. This star sits about 9,500 light years away from Earth, in a part of the sky called the constellation Scutum. It was first catalogued by astronomers way back in 1860, but it was not until much later that scientists truly understood just how enormous it is. UY Scuti is currently one of the largest known stars in the entire universe by physical size. Its radius is estimated to be around 1,700 solar radii. Let that number sit for a moment. 1,700 times bigger than our sun. If you replaced our sun with UY Scuti right now, the surface of that star would extend past the orbit of Jupiter. Not Earth, not Mars, not Saturn, Jupiter. The largest planet in our solar system would be sitting inside UY Scuti. Mercury, Venus, Earth, Mars and Jupiter all completely gone, swallowed inside one single star. Let us try to understand that size in a different way, because numbers alone do not always help the brain picture what we are really talking about. Light travels at 300,000 kilometers every single second. It takes light about 8 minutes to travel from the sun to Earth. If you wanted light to travel all the way around the outside of UY Scuti, it would take about 7 hours. 7 hours for light moving at 300,000 kilometers per second to go around the outside of one star. If you tried to drive around UY Scuti in a car at highway speed, not stopping for anything, it would take you roughly 2,500 years to complete one full loop. That is how big this thing is. That is what we are dealing with. Now you might be wondering, if UY Scuti is this enormous, why have most people never heard of it? Why is it not more famous? The answer is that size and brightness are not the same thing. UY Scuti is massive, but it is not the brightest star in the universe. There are other stars that are smaller in physical size but burn so intensely hot that they outshine UY Scuti easily. Stars are measured in different ways. You can measure them by size, by mass, by brightness, by temperature. UY Scuti wins when it comes to sheer physical volume. Think of it like comparing a very large but cool campfire to a small but incredibly intense blowtorch. The blowtorch burns hotter and brighter, even though the campfire is much bigger. UY Scuti is what scientists call a red hypergiant. The word hypergiant tells you it is beyond even the supergiant category that Betelgeuse belongs to. These are the most extreme stars that exist. Regular stars like our Sun fuse hydrogen into helium in a steady and stable process that can last for billions of years. Our Sun has been burning for about 4.5 billion years, and it has roughly another 5 billion years left. A hypergiant like UY Scuti burns so intensely and uses up its fuel so fast that its lifespan is tiny compared to our Sun. While our Sun will live for around 10 billion years total, a hypergiant might only last a few million years before it runs out of fuel. In cosmic terms, that is almost nothing. It is like a candle that burns incredibly bright but goes out in minutes, while a smaller candle burns steadily for hours. What happens when a star like UY Scuti finally runs out of fuel? This is where things get really dramatic. When a massive star exhausts its nuclear fuel, the outward pressure that was holding the star up against its own gravity suddenly disappears. Without that pressure, gravity wins instantly, and the star collapses inward on itself at incredible speed. And then it bounces back outward in one of the most powerful explosions in the entire universe. This is called a supernova. A supernova explosion releases more energy in a few seconds than our Sun will release in its entire 10 billion year lifetime. For a brief moment, a single exploding star can outshine an entire galaxy containing hundreds of billions of other stars. And depending on how massive the original star was, what gets left behind after a supernova can be either a neutron star or a black hole. Now let us talk about something that might make this feel a little more personal. UY Scuti is so far away that it poses absolutely no danger to us. 9,500 light-years is an enormous distance, and we are completely safe. But Betelgeuse, the star we mentioned earlier, is only 700 light-years away, and Betelgeuse is expected to go supernova at some point. Scientists are careful to point out that in astronomy, when we say at some point, we mean anywhere from tomorrow to 100,000 years from now. We genuinely do not know exactly when, but when it does explode, people on Earth will be able to see it in the daytime sky. It will be brighter than the full moon for weeks. You will be able to look up in the middle of the day and see a star exploding 700 light-years away. It will not harm us at all, but it will be one of the most spectacular things any human being has ever witnessed. One of the most interesting things about UY Scuti is how we actually measure a star that is 9,500 light-years away. We obviously cannot send a spacecraft there. We cannot put a ruler next to it. Everything we know about this star comes from studying the light it sends us. Scientists look at how bright the star appears from Earth, and then using mathematics they calculate how far away it is. Once they know the distance, they can figure out the true brightness. And from the true brightness, they can work out the temperature and the size. All of this from nothing but light that has been traveling through space for 9,500 years before it reaches our telescopes. The light you would see if you looked at UY Scuti tonight left that star 9,500 years ago, back when ancient civilizations were just beginning to write things down. There is something else worth thinking about when it comes to stars this size. UY Scuti is so large and its gravity is so powerful that it is actually losing mass. The star is so enormous that material from its outer layers is constantly being blown away into space by its own radiation and stellar winds. UY Scuti is slowly evaporating. It is shedding its own outer layers out into space, creating a massive cloud of gas and dust that surrounds the star. This is actually common with hypergiants. They are so extreme that they cannot fully hold themselves together. They burn fast, they lose mass fast, and they die young by star standards. UY Scuti is in many ways a star that is too big for its own good. So what does all of this tell us about the universe we live in? It tells us that the scale of everything out there is almost impossible for a human brain to fully grasp. We live on a planet that feels enormous to us. Our oceans are vast, our mountains are tall, and yet Earth is a marble next to the Sun, and the Sun is a tiny dot next to UY Scuti. And UY Scuti is just one star among hundreds of billions in our galaxy. And our galaxy is just one among hundreds of billions of galaxies in the observable universe. The universe is not just big, it is so big that the word big does not come close to describing it. Every time we think we have found the largest thing we can imagine, space shows us something larger. And yet here we are on this tiny marble, looking up at the sky, figuring it all out, building telescopes, studying light, calculating the size of stars 9,500 light years away. That is what makes us remarkable, not our size. We are small, we are incredibly small, but we are curious. And that curiosity has allowed us to understand things that are almost beyond understanding. UY Scuti has been out there for millions of years. It has no idea we exist. But we found it, we measured it, we understood it, and now you know about it too. That is it for today. If this blew your mind, make sure you subscribe, because next time we are going deep into something that will make even UY Scuti seem small. We are talking about the largest structures in the entire universe. Things so big that galaxies look like dust next to them. You do not want to miss that one. Thank you for watching, and I will see you in the next video.